As number 8 says we have this as our function. Okay. It says find the slope. So if I find the slope, how do I find the slope? What do I have to do to find the slope? Do what? I have to find the derivative first. So the derivative is 8x plus 3. And then they said they want us to find the slope at x equals 2. So I'll take 2 and plug it in here, which is 16 plus 3. So I find that I have a slope of 19. Okay? So that basically means on this graph, it's probably a parabola at 2. We're trying to figure out that slope. That slope right at that point, that slope right there would be 19. And I realized I just hand drew a slope. So you're like, how do you know that's 19? I just made it up off that. Okay? Then it says, find the equation of the line tangent at x equals 2. Okay? So what I want to do with this, I'm going to plug this back into the original equation. So I get 4, 2 squared plus 3 times 2. So that's 16 plus 9, which is 25. So that means the point 2 comma 25, this exists on my original graph. And then from there, you're going to go y minus y1 equals m times x minus x1. So that's x1, that's y1, that's m. So just plug them in. So you get y minus 25 equals 19, x minus 2. If you want, you can clean that up. But that particular equation, that's a straight line. You don't have to clean it up. Desmos would easily do it for you. So I'll give you a sec to get that copied down if you needed to. What's that? Oh, it's 16 times 6. So that should be 22. Yes, thank you. Should have been 22. 2. That should be a 22. Sorry about that. All right. So basically what this means is if I look at this, oh, that's those people. Let's go to Desmos. So if I were to graph not a normal distribution, but if I were to graph y equals 4x squared plus 3x, and if I go to my home screen, so there's my parabola. And then if I were to plot the point, it was y minus 25 equals 22 is the slope, is that right? And then x minus 2. Okay, so this point of tangency, nope, that's not it. So let's find this point. Table. Find the point 2 comma 25, which is up here. 2 comma 25. 4x squared. Is my equation right?
Slope 19, and then
Do what?
slope might be 19, and then
let's see, 16 plus 6 is 22. I plug 2 into the derivative. Oh, wait. Did I make a mistake? If I plug 2 into the derivative, I plug 2 in that, that's 19. So that should be 19. My goodness, I'm just making errors all day long. Oh, wait. Slope is 19. Okay, I see what you're saying. That okay. So, and that's 22. So that should be 2 comma 22, right? And slope of 19. So I have to change my equation. My equation's wrong. Can't take me anywhere these days. So I get y minus 22 equals 19 and x minus 2. So if I plug that in, that should work better for us. Y minus 22. Slope is 19.
Yes.
There we go. And then the point 2 comma 22. There we go. That right there is my point of tangency. So that's where if I zoom in on this point, the green line is the straight line. And it kind of looks like it's riding right along the blue line. Let's zoom as much as we can. We should eventually start seeing a difference. Should start seeing the blue. Yeah. I can assure you the blue line is somewhere in there. It's just that I made one thick, one thin. Let's see if that's going to work. That didn't work. But that's the point of tangency of that particular equation. All right. Can we go to number 9? All right. Problem number 9 says we have y equals x to the third minus 3x squared plus 5. We want to figure out stuff at x equals 1. So we want to find the line tangent to it. So I'm going to go y prime equals 3x squared minus 6x. If I want to find the slope, I'm going to plug 1 into this. So that's going to give me 3, 1 squared minus 6 times 1, which is 3 minus 6, which is negative 3. That's our slope. And so then if I wanted to find the point that works here, I'm going to take this 1 and plug it into these x's. So I'm going to get 1 to the third minus 3 times 1 squared plus 5. So that's 1 minus 3 plus 5. 1 minus 3 is negative 2. Negative 2 plus 5 is 3. So the point 1 comma 3. So that's x1, y1. And now we can use our point slope and plug it in. So I get it. 1 minus 3 equals negative 3x, excuse me, minus 1. So this is my equation. That's my equation. Y minus 3 equals negative 3 times quantity x minus 1. That is the tangent line to our parabola, or it's not a parabola, it's actually a third degree, so it looks like this. I think got goofy. That's what a graph looks like. So if it was a negative, I'd say it's happening somewhere in here because you have a negative slope. So let's just verify that on Desmos. Clear these bad boys out of here. So I get y equals x to the third minus 3x squared plus 5. Go back to home. So there's my graph. And our other equation is going to be y minus 3 equals negative 3x minus 1. So this is the point they're talking about. So notice this point of tangency actually kind of goes through the graph twice, and that happens on a third degree polynomial. If you graph the derivative, it's going to show like the end behavior, which is fine, but we're not going to deal with that. All right, number 10. We have f of x is equal to x to the fourth minus 4x to the third plus 9. Let's find the derivative, f prime at x. That's 4x to the third minus 12x to the second. And we want to see if this has any horizontal tangents. So where would f prime at x, where would f prime at x be equal to 0? So you can solve this. Equals 0. I'm going to come down. So it looks like I can factor a 4x squared out of there. That's going to leave me x minus 4 equals 0. So if 4x squared equals 0 and x minus 4 equals 0, solve both. Yep. So x equals 0 is where it's going to have a where the horizontal tangents take place, and at x equals 4. So if we utilize those, I'll show you what's going to happen. Can I go to Desmos, or anyone still copying? All right, so if we graph this, I have change it to y equals x raised to the 4th minus 4x raised to the 2nd plus 9. Okay, so here, oh wait, did I do something wrong?
Should be X minus 3.
Hey, what's up? Can you what? What are you doing? Are you off at third? Or wait. Yeah. Class 4. Like the little ones, the mini ones? Yeah, let me grab them for you. If you were taking this in Algebra 2, that would have been a wiggle. All right, last one. There's my mistake, because that should have been a third. That should have been a third. Yeah, there's I made a mistake in there. All right. And then number 11, we have y equals 5 minus 2 root x. We're going to figure this, find out the tangent line. So I need to make sure I know that this is to the 1/2 power. If I take the derivative of that, that's going to give me 0. This is going to give me half of -2, which is -1 x. Now I'm going to subtract 1 from that, or 2/2, so that's -1/2, which is cleaned up. That's basically what's taking place there. So if I wanted to take 4 and plug it in here, I'm going to get -1/√4, which is -1/2. This is my slope. And if I take 4 and plug it in here, I'm going to get 5 minus 2 times the square root of 4. Square root of 4 is 2. So 5 minus 4 is equal to 1. So at the point 4, 1, that's x1, y1. And so if I plug into my point slope equation in math, I'm going to get y minus 1 equals -1/2 x minus 4. I don't know if you can see that. I'll rewrite it down here. And that's that's our equation. All right, you guys got all what you needed to get. I'm sorry, choking on something. All right, so let's have you guys work on the 4-1 to 4-3 practice quiz. And let's have us do just the front page of it. And happy to help you on that. This will actually be due on Monday, because on tomorrow we're going to talk about why we should not go to rent-to-own stores. And that will be your salesman Rex. Sound good?